Given a set of parametric equations, as t increases, we travel along the parametric curve in a particular direction, and this is called the orientation of the curve, and we can indicate that by arrows. Non-obvious things can happen. The curve may pass through a section of the curve repeatedly, and it may also travel along sections of the curve in different directions for different values of t. Here's an example where the parametric curve passes through a section of the path more than once. So let's look at the parametric curve described by the equations x equals sine 2t, y equals cosine 2t. And here the t ranges from 0 to 2 pi. So we start with t equals 0 at the initial point, which is 0, 1. And this is at the top of a circle of radius 1, where the x is 0 and the y is 1. When t increases to pi over 4, the corresponding point on the curve is the point 1, 0, which is to the right of the origin with x equals 1 and y equals 0. When t is pi over 2, we get to the point x equals 0, y equals minus 1, and when t equals 3 pi over 4, we're at the point minus 1, 0, which is to the left of the origin. Now, when t reaches pi, we get back to the initial point again. When t is pi, sine 2t is 0, and cosine 2t is 1. So as the t runs from 0 to pi, our path runs right around the unit circle from 0, 1 right back to 0, 1 again. And then as our t values run from pi to 2 pi, we move right around the circle again. And if we graph these points that we found, we see that the first one is 0, 1, then we get to 1, 0, 0 minus 1, minus 1, 0, and then they start to repeat. At pi, the corresponding point is 0, 1. When t is 3 pi over 2, the corresponding point is 0 minus 1, and when t equals 2 pi, the corresponding point is 0, 1. We see that all of these points lie on the unit circle, and that the curve sweeps around it twice in a clockwise direction. Let's have a look at what's going on using Mathematica. As t increases from 0 to 2 pi, the curve traced out by the parametric equations x equals sine 2t, y equals cosine 2t starts at this initial point above the origin x equals 1, y equals 0. And as we increase the value of t to t equals pi over 4, we sweep around that arc of the circle in the first quadrant to the point 1, 0 when t equals pi over 4. And as t runs from 0 to pi, we get one full revolution of this circle, and when t is pi, we end up at the initial point again. Now, as t increases from pi to 2 pi, we don't get any new points. This parametric curve moves around the circle again from the initial point right back to the initial point. Note the curves in example 1 and 2 look exactly the same. They're both unit circles, but as we trace out the curve, we're tracing them out in different directions. When our parametric equations are x equals cosine t, y equals sine t, we move exactly once around the unit circle in a counterclockwise direction, starting at the point 1, 0 and ending at the same point. In the second example, where x equals sine 2t, y equals cosine 2t, we move twice around the unit circle, starting at the point 0, 1, and we're also moving in the opposite direction to the previous one. We're moving in a clockwise direction.